Hello students, welcome to all of you in this video lectures. Here I am going to continue the chapter 10. The name of the chapter is Vector Algebra. Okay. In the last video lectures I have explained few terms related to this chapter, and today also I'll discuss some more definitions and will solve few questions based on that. The first one is scalar product. What is the scalar product or dot product of two vectors? Let A and B be any two non-zero vectors. Let A and B be any two non-zero vectors, right? Inclined at an angle theta. Inclined at an angle theta. The dot product of or scalar product of A and B, vector A and B, can be defined as A dot B equal to magnitude of A into magnitude of B into cos theta, where theta lies between 0 and pi. So you can see that these are two vectors A and vector B, and angle between the vector is theta. Then A dot B can be defined by A dot B equal to AB cos theta. This also can be written as A dot B equal to AB cos theta, right? Now there are some properties of dot product. Properties of dot product. Number 1, dot product is commutative. Dot product is commutative means A dot B can be written as B dot A, right? Number 2, dot scalar product is associative with respect to a scalar. Okay, it is associative with respect to a scalar. For example, M into A dot B will be same as M A vector dot B, M A vector dot B, or it is same as it is same as A vector dot M B vector, right? Third one, dot product follow distributive law. What is distributive law? A dot B plus C can be written as A dot B plus A dot C. Next one is very important. Projection of A on B. Projection of A on B can be defined as A dot B divided by magnitude of B, and projection of B vector on A vector will be A dot B by magnitude of A. Student, I hope all of you understood. Projection of A vector on B vector is A dot B by mod of A, mod of B, and projection of B vector on A vector is A dot B by modulus of A vector. Right? So next is number 5 properties. Angle between two vectors is cos theta equals to A dot B by mod A mod B. Now if A vector is parallel to B vector, then theta will be 0 degree, right? So therefore cos 0 degree A dot B by mod A vector into mod B vector. So in that case A dot B vector equal to mod A vector into mod B vector. If A vector is perpendicular upon B vector, then theta equal to 90 degree. So cos 90 equal to A dot B by mod A into mod B. So cos 90 is 0. So in that case A dot B vector equal to 0. So students, for two parallel vectors we have this A vector dot B vector equal to AB, and for two perpendicular vectors we have A vector dot B vector equal to 0. The next one is next topic that I am going to discuss is vector product. Vector product, or is also known as cross product, right? It is vector product or cross product. So students, the cross product between two vectors A and B is A cross B equal to mod A mod B sin theta into n cap. Students, n cap is the unit vector where n cap is the unit vector perpendicular to both vector A and vector B. So students, next I'll show you some properties of vector product. Number 1, if A cross B equal to 0, then either A equal to 0 or vector B equal to 0 or A vector is parallel to B vector, right? Because in that case the theta will be 0 degree. If A cross B is 0, then sine theta will be 0 degree, then only this part will be 0. And if theta is 0, then the two vectors A and B are said to be parallel, right? Next properties is angle between two vectors is sin theta equal to mod of A cross B by mod A into mod B. Now, how to find A cross B? We can use the determinant I, J, K. A1, A2, A1 you can say B1, C1 and A2, B2, C2, where vector A is A1 I cap, B1 J cap, C1 K cap, and vector V is A2 I cap, B2 J cap, C2 K cap. Now, using this determinant, we can calculate the cross product A cross B. Students, number 4, cross product do not follow commutative rule. commutative law as A cross B equal to minus of B cross A. 5. Distributive law, it follows A cross B, A cross B plus C can be expressed as A cross B plus A cross C. Area of a parallelogram whose adjacent sides are vector A and vector B is mod of A cross B. And number 7, area of triangle any two sides having position vector A vector and B vector is half mod A cross B. So students, these are some properties of cross product. Now I will discuss about section formula, right? Section formula. Let P and Q are two vectors and R vector divides PQ in the ratio m is to n. The position vector of R is vector R. So let P and Q are 2 points whose position vectors OP vector and OQ vector. Okay, P and Q are 2 points whose position vectors are OP vector is taken A vector and OR vector OQ vector is taken V vector. Let R divides PQ in the ratio m is to n. So the position vector of R is OR vector m B plus n A vector divided by m plus n. If it is internally, and if R divides externally, then position vector of R will be m b vector minus m vector by m minus n. So students, these are few theories of the chapter vector algebra, which is very important to know. I am ending today's video lectures, where I have discussed about scalar product and the properties, vector product and the properties, and projection of one vector to other vector, and also about the conditions for parallel lines, perpendicular lines, angle between the lines, and at last I have discussed about section formula. So please go through it, it is very important. In the next class I will start solving questions from the exercise 10.1, 2 and 3 onwards, and if there is any confusion, you can contact me. Thank you very much.